Okay, so the first question says, use the exchange rate £1 to $152 to answer the following questions. Now, this is a non-calculated exam, and this is a non-calculated question, okay? Now, to change pounds into US dollars, we always times by that number there to change into that, and to change it back, we divide, because anything divided by itself is 1. 1 times by anything becomes a new thing. Now, the only way they'll be able to put this into a non-calculated paper is if this number is nice, and it is. 300 times by a decimal is very nice. It's just going to move the decimal 2 places because there's 2 zeros. So what I've done by here is that it says £300, so I'm on pounds, get to dollars, so I'm timesing by 1.52. I've then split my 300 into 3 times by 100. I then did 100 times by 1.52, which came to 152, and I then times that by 3 to get 456. The next word, the key word here, as I've already highlighted, is estimate. It says Adrienne wants to exchange $585 into pounds. Estimate how many pounds Adrienne is likely to receive. The best way to estimate, well, this would be the calculation you need to do. You need to do how many dollars she has, and then divide it by the exchange rate. And the best way to do that is to round that to the nearest significant figure. So this has changed to 600 and this has changed to 2. You could argue that this is 1.5, which would be more accurate, but it would be harder maths, and then as a result, you are likely to find the question harder, and this would still get you full marks. Question 2 shows a map, and it says the map below shows the route from Edinburgh to Dundee. It then tells us in the question, it says that the journey of Edinburgh to Dundee is approximately 4 centimetres on the map. The actual journey is 1,000 kilometres. And in the question it says, go and write the scale in the form 1.2, and it leaves a blank line. You're going to see that now as soon as I sort of reveal the answer. The one thing I'd tell you to look out for here is that this is in centimetres and this is in kilometres. And then to have these things compared in a 1-2 form, they need to both be in the same unit of measure. I wouldn't like to change 4 centimetres into kilometres, so it would be an absolutely tiny answer. This I'll change into centimetres, so it's going to be a huge answer, just to warn you, okay? So the bit of maths I've done is I've changed 100 kilometres or kilometres into 100,000 metres, and then I've times that by 100 to change that into centimetres, because K stands for times by 1,000, C stands for times by 100. I've then put that in the form 4 centimetres is equal to, 10 million centimetres, and then I've halved both of those to get 2 centimetres is 5 million centimetres, and then I've halved again to get 1 centimetre is equal to 2.5 million centimetres. The next question says, the journey from Edinburgh to Dundee takes 2.5 hours by car. Calculate the average speed of this journey. So you can maybe see just here, you can see the tip or something. That'll be my speed distance time triangle. Watch out for this, it's very easy to go wrong there. That is not, it's not 2.30 into the, when you're working with it, okay? 2.5 hours is 2 hours 30 minutes, and a half is 0.5. So my calculation should be as follows. Speed is equal to distance divided by time, so I've subbed in those numbers. I couldn't do that without a calculator, so I doubled top and bottom to keep it the same fraction, and then I answered that. 5 goes into 200, 40 times, so it would be 40 kilometres an hour. Okay, question 3 was about a scatter graph, and it gave you these points, and the first thing you had to do is go and plot all those points, and you can sort of see all my answers here. So as you can see, I plotted these as points here, so 104 there, stopped at 510 because it was this pair here, and then so on and so on and so on. Now you can see here I've already drawn my line of best fit in here. Your line of best fit should predict where the data is going. It does not need to go through this point here. That is a common misconception. There's no need for it to go through there. And in terms of anything else I need to mention, yeah, hitting the axis here is absolutely fine. Question E came first by accident, and this should have come at the end, but it's not the end of the world. It says approximately is another word for an estimate. How much does a customer spend on average in a sandwich shop? And you can see I've highlighted the keywords here. Approximately, so estimate, a customer means one customer, and on average, okay? So I need to do the total number of sales, so that's what I've been doing by here, the total number of customers and the total number of sales. Now you can see I've added those up by here. I couldn't do that in my head, I had to add it up like that, and similarly here I had to add the takings up by there, and that's maths from back in the day. You can still do it, it's just going to take a bit of time. And because it was approximately, I rounded those numbers again, so you can see here, I've tried to colour code it, that 2,740 I changed to 3,000, that 358 I changed to 400, cancelled the zeros, and then did 30 divided by 4, so half of 30 is 15 and half of 15 is £7.50. It says write down the type of correlation that's shown by the scatter graph, and that would be positive. Draw a line of best fit, I did. Estimate the takings for when there is 90 customers. So you can see by there, is that working? Yeah, I put in a point at 90. I've drawn up there and come across to read off my value there, and I had to read the scale, which was 500. No, it wasn't. It was 440. Okay. Okay, question 4 says, you must show all your construction arcs. Using a ruler and a pair of compasses, construct an angle of 45 degrees at the midpoint of the straight line. Label your angle 45 degrees. Okay, there are only 2 angles that you will need to draw, and at any point, you need to know how to make 90 degrees and 60 degrees. 90 degrees you create by having a line, open your compass to more than halfway, drawing arcs at each end of the line halfway, and then bisecting that. That'll make 90. And to make 60, you draw a line, and then you open your compass to the length of that line. You draw basically an equilateral triangle at the end of each line, and then where they cross there and there, that would be an equilateral triangle. Okay, but this says make 45 degrees, so you've got to try and find a link either between the 60 and 45 or the 90 and 45. And there's the link, 90 and 45, and the link is this is half of 90. So what we're going to do is we're going to make an angle of 90 degrees. So you can see by here, I've got my straight line, I've opened my compass to more than halfway of the line, I've drawn this arc here, and then left the compass at exactly the same width, put the point on this end here now, and drawn this arc by here. Where these 2 things crossed, I lined my ruler up and drew a straight line down, and that made an angle of 90 degrees. I then bisected this angle by opening my compass to around about 3 centimetres. I put my point where these 2 lines cross here and drew an arc like that. I drew blobs here and here because that's where my compass needs to go now. I then drew this arc, moved my compass at exactly the same width, and drew this arc. Where they cross and where the angle meets, I drew a straight line, and that angle there and there will both be 45. This question was very, very similar. It wanted us to create this diagram. It's given us a scale to use here. 1 centimetre is equal to 4 centimetres. So here, that's 48 centimetres. But if 1 centimetre is equal to 4 centimetres, I need to divide that by 4 in my drawing, so that will really be 12. And here, that one will really be 10. Now, to make 30 degrees, if I go back to the previous page, I just showed you that you need to either know 90 or 60. Well, the link between the 2 angles is that 30 is half of 60. So what I want to do is create that angle of 60 degrees, but then I want to bisect it to make 30 degrees. So you'll see all my working by here straight away. So I had this line was already drawn in for me, and if it wasn't, I could just draw it in. I then put my compass by here, and I drew that arc there. I then moved my compass point to here, and drew that arc in by there. And I drew that blue line in afterwards. I went up quite a way, as you can see. I could have stopped by there if I wanted to, but I went all the way by here. And there's no need to draw it quite that far, but that's what I did. Okay. I've then bisected the line by keeping my compass at this length here, this width here. I've then put my point here and drawn this arc. I then put my point here and drew this arc. And where they cross, I drew a straight line going through them, which was exactly 10 centimetres long, and that meant that this angle here and here were both 30. So I can say 30 degrees there, 30 degrees there. Now, I've done this on my iPad, so I don't really know what the answer is here to this bit, okay? As long as you've done it to scale, you should get the right answer. So that was 10, and that was 12, and that was 30. Then you'll go measure that line there. You'll find it in centimetres, and it says find the actual length. So to find the actual length, that whatever this one is, you'll then times that by 4, and it will equal the actual length in centimetres. Okay, so I'm assuming that you've read the question in your own time. I'm just going to go through this answer. Okay, the key bits in the question are that Pedro uses 700 metres cubed of water every 3 months, and I think these come every 3 months. Yeah, so everything's like sort of matching up here, which is fine. He wants to spend as little as possible, don't we all, on bills. Which company should he go for? Well, I'm going to work with Manea Water first, and I'm going to do some work over by here. Now, very similar maths used here again to which I've already used in the paper. I did the number of units of water used, so 700 times by the price he pays per metre cubed. I can't do 700 times by 0.06, I don't know what that is, so I split the 700 up into 7 times 100 times 0.06. Then I answered this bit, which is 6, and then 7 times 6 is 42. So it's €42 every 3 months. I then did the same sort of thing over here for channel water. So I did 700 times by 0.02, split, found it's the same as doing 7 times 2, which is €14, but I have to pay €30 every month, even if I don't use any water at all. Okay, so that came to £44 every 3 months. So on the face of it, that answer there is the best one. Okay, but we were told that there's a special offer on your first bill, you get 20% off. So what I've done here is I've worked out 20% off the first bill. So I started by finding 10%, divide by 10, double it to find 20%, and now I need to take that off because it's coming off my bill. It says 20% off your first bill. So then I would do 44, take away £8.80, and I had to do it like this. And the point I made here is that this is for the first bill, so after that, it's cheaper for the first bill, but every bill after that would be more expensive. And there's no right or wrong answer here. You can actually choose either one. You can either say, I choose this one because it's cheaper every month in the long term, or you can say, I choose this one because to begin with it's a better deal. You could even say, I choose this one and then change over to this one if you want to. Okay, please make sure you've read this question. It's important you understand what it's telling you. It says, the town's drama club carried out a survey asking people as they left a local theatre. It then says, why is this a biased survey? Well, it's biased, not because of like the ages and there's big gaps between the ages or anything like that. It's biased because they are a drama club going outside a theatre. So they're probably likely to get a certain amount of people who are going to say, yeah, drama's great. If you went down to like a boxing club or something like that, you'd probably get a very different answer. It's biased because they've gone to somewhere that they're likely to have people who like what they do. Okay? Nothing to do with ages or anything like that. State 2 criticisms of question 2. So we're only interested in this one here. This one here is not a good question here because these are very vague ways of doing this. How interested are you in drama? No interest, some interest, very interested. They're too vague. We can't measure those things. But it's question 2 that it's interested in. 2 criticisms. Well, the ones I've got is 50s in both categories. If I was 50, I could go into that one there or that one there. And it's not rude to ask people their ages or anything like that. That's not an answer. I've seen that written down loads of times in the past. The other one is there's no option for over 75. So if you're 76 or older, you can't tick any boxes. So that's a criticism of that question. Part C, it says, what's the problem with the designer question 3 in the survey? Well, we don't like this sort of question. We prefer to get tick boxes because they're very, very easy to sort of like digest the data and look to see exactly where people are. This would require lots of reading and lots of analysis of the data. Is what we call a qualitative answer, which we don't really need to worry about. We basically just want to have tick boxes, okay? And the reason why, because it's very easy to process the data, and that's the point I made here. So I've said, could get long responses, tick boxes for quicker processing of the data, okay? Again, please make sure that you've read this question and familiarise yourself with it. I'm not going to go through the question in detail. I will go through the maths in detail, however. It says machine A makes 180 plastic spoons per hour, machine B makes 240 plastic forks per hour. Both machines start their production on Monday morning at 9. Both machines are stopped for maintenance after 450 spoons have been produced, so I'm working with that one. It says calculate the time at which the machines were stopped, the number of forks that have been produced between 9 and the times that they were stopped. So, the first thing I did was I started to write out like this, and there's 2 ways of doing it, and I've shown you both. In 1 hour, 180 spoons made. In 2 hours, 360. In 3 hours, 540. I'll keep on adding 180. And you can see there, it's clearly not as long as 3 hours because that's over 450 spoons. But what I did spot, I was just like, well, hang on. I just sort of spotted that 450 was in the middle of these two here, which isn't the easiest thing in the world to spot. So I've shown you another way of doing it. It's basically doing 450, which is the number of spoons that have been made, divided by the number of spoons per hour. I obviously don't know what that is, so I divided top and bottom by 10 to begin with. And then I've divided both of those by 9. So 45 divided by 9 is 5, and then 18 divided by 9 is 2. And then 5 divided by 2 is 2.5 hours. Okay, so these are both the same answer, both perfectly acceptable ways of working out. You don't have to do both at all. So I said that the machines are stopped at 11:30 because that is 2.5 hours after 9. So now I need to work out the number of forks that were made. And that would be 2.5 times by 240. And I've gone about it in the same way. I worked out 1 times 240, 2 times 240, then 3 times 240, then 2.5 must be in the middle. So I found what was in the middle of that. But there are other ways to go and find it. You could times by 5 and then half that, or you could times by 10, half and half again. It's up to you. Okay, there's a few different ways to do it. Again, please make sure you familiarise yourself with this question. It says that David works as a manager in a department store. He gets £17,000 per annum, which means per year, and he usually receives a bonus every year. David has the right has a choice to make which bonus he wants. He can either have the smaller share of 2,500 shared in the ratio 2 to 3 with his section manager, or he can have 6% of his salary. So if we come down here, I've got him worked out what the ratio is. So to work out the ratio, you would add the two parts together to get 5. You do the the amount of money divided by 5, which is £500 for one part, and then because it was in the ratio 2 to 3, we times it by 2 and 3, but I've only worked out the 2 bit because he gets the smaller, where is it, where's my thing here? He gets the smaller ratio, so I only did 2 times 500, so he'd get £1,000 getting the smaller share. Okay, now it's important that I put little arrows explaining what I'm doing here, because it says at the top here, I'll be assessed on the quality of my written communication, and I put a few of these in this paper. You'll only get one in your exam on Thursday, but I put a few in just to give you that sort of chance to practice that, okay? It's only worth 2 of these 7 marks as well. It'd be worth 5 for the math, 2 for this sort of written, your calculations nice and clear, putting pound signs and final answers, etc., etc. The other one I need to do now is work out 6% of his salary. So I worked out 10% to start. I then halved that to find 5% and divided by 10 to find 1%. So half of this was 850, and then this divided by 10 was 170, and I stacked them then to make it easier for me to add them. So I did 850 add 170, and that came to 1,020 quid, and then I finally then made the conclusion that 6% of his salary was better, only marginally better. It's only 20 quid more, but 20 quid is 20 quid nonetheless. So if you've got the choice to get 20 quid more, surely you'd want the extra money. Okay, this question here, the best advice I could give you around parallel lines is to make sure that these two are pointing nice and flat. If they weren't, I would recommend actually rotating your page like that to make sure they're nice and flat. So if the question came like that, physically pick the paper up and rotate it so it's nice and flat in front of you, okay? We want these two things just pointing that way to the side. Now I know that, I can start putting in lots of 105 degrees. I know all along this line here that these angles opposite must be 105, and then these two obtuse angles up here must be 105. Now, truth be told, working out those angles was absolutely no use to me, but it wasn't very hard to go and fit them in. I then worked out this was 75 by doing angles on a straight line. That meant the opposite angle must be 75, and then the same process of elimination here. These must be 75s as well. Now, I've got a triangle here, so as you can see, I know that's 75 here. I know that's 50, so by the side of my work, I've added that. 75 add 50 is 125. Angles in a triangle add up to 180. So this is 55, as you can see. I've done that working out here. And then if that's 55 and 55, all the acute angles along here are 55 and 55. I didn't bother finding the obtuse because I wasn't asked to find them. X is 55. We were asked another question here as well. It says, Martha has another flower bed in the shape of a parallelogram. The longer sides are twice the length of the shorter sides of the parallelogram. The perimeter of the flower bed is 24 metres. Let the length of one of the shorter sides be z metres. Form an equation in terms of z. So I solved my equation. I did that by actually drawing a parallelogram. So my parallelogram looks like a pushed over rectangle. That's what parallelograms look like. I was told one of the shorter sides is z, so I put that z. And because the longer side is twice the width, I put that as 2z. I then put that the same, like I said, it's a pushed over rectangle, so these are the same, these are the same. And then the perimeter is one lap around there. So I said p is equal to z plus 2z plus z plus 2z, which is 6z. And then I changed the p to 24 because I was told it was 24. And then I took the 6 over and divided by it and found out that z was 4. Okay, question 9 was quite a tricky question, actually. I didn't think it was very easy at all. First of all, the first thing I've noted, I know this is a negative gradient. It looks like a negative correlation in terms of scatter graphs, and we should know that that sort of line doing that is in the negative gradient. The next thing I've noted is that it crosses the y-axis. Its y-intercept is positive 1.5, so it's plus 1.5 there. And as you can see, I've highlighted a triangle. As long as you draw a triangle somewhere, it can be smaller or bigger than that. I've chosen what I think is a nice one, which is my rise over run, which is 1.5 rise and then 4 as my run. So I've gone and worked out the gradient over here. So my gradient rise over run, so my rise 1.5 over 4, and then I doubled because you're not supposed to have decimals and fractions, which is 3 over 8, but as I've stated earlier, this was a negative gradient, as we can tell by here, so that just means all I have to do is whack a negative sign in front of 3 over 8. It then says, go and work out which graph it is. And as you can see, well, we know what the answer is now. It's this one here I've highlighted. But I can eliminate loads of these answers. This one here gives a gradient of -4. Well, I know my gradient is -3. In fact, actually, I've got the equation written here in the terms of y equals mx plus c as y equals -3x plus 1.5. So I need it to be exactly the same as that. This isn't. That says y equals -4x. So it's not that one straight away. I eliminated it. This one here's got no y-intercept, so I got rid of that straight away. This one here has a gradient of 4, eliminated straight away. This one has a gradient of -0.5, eliminated straight away. So that leaves me, it's between 1 and 2. So what I did was I rearranged question 1, or equation 1, here to be in the form y equals. At the moment it's 8y. I want it to just be y. So what I did was I divided every bit by 8. So 8y divided by 8 cancels the 8s. 3x divided by 8 is 3/8x. And then 12 divided by 8 is 1.5. Now that is nearly my equation, but it hasn't got the minus, so it's not that one. But then, as you can see with equation 2, I get exactly the same formula as I worked out over here. Okay, so that's how you do that type of question. Okay, again, this sort of question can come up on a non-calculated paper, but they've got to make sure the maths is pretty reasonable, and this is the way we solve it anyway. It says that Harriet invests money into a savings account, pays 3% per annum, no further deposits or withdrawals are made. The spreadsheet is used to calculate the total amount in pounds A in Harriet's account. It says, how much did she initially invest in her account? Well, we always do that as money times by the 100% plus the interest rate to the power of number of years. So that is the money there. So the answer is 220 quid. It then says calculate the amount of money she'd have after 1 year. Now, ordinarily, we just go and put into the power of 1 there, but we can't. Now, this 0.03 means we're at 3% per annum. So all we need to do is go and find out what 3% is. And I'll tell you one thing I didn't do here. I'd lose one of these 2 marks. Is that's the rate of interest. I now need to add it on to the 220. So it would be 220, add £6.60. Which would be £226.60p. Okay, this question on Boxplots, you should know that this is the min value, you should know that this is the max value, this is the median, this is the upper quartile, and this is the lower quartile. Write down the median score, 30. Literally just finding it there, middle line there, 30. Write down the highest score. The highest score, 48. Again, reading the scale, 48. Work out the interquartile range, the upper quartile, so 35, take away the lower quartile, so 35, take away 29. Oh, hang on, there's a mistake there, isn't there? That's not 29, it's 19. Okay, just while I'm going over it then. So that should have been 60, okay? And then Martin scored 35 marks. What percentage of the class scored a lower mark than Martin? Okay, so he scored 35 marks, and we're looking for people who were lower than Martin. So where's 35? 35 is here, and we're looking for all of these people here who are lower than him. All of these people are. Now, how much is that? Well, this is split into quartiles. So this would be 1/4. Hang on, let me get rid of that. And again, so this would be 1/4, this would be a half, this would be 3/4. And we're interested in everything this side, so 3/4 people did worse than him, so we just need to change that to a percentage, so the answer is 75%. Okay, this question is a very hard question, and you should be finding this really, really tricky. It takes a lot of visualization of what's going on in the question. It says, the diagram shows a cylinder. It says the cylinder has radius r and height h. The points P and Q are on the circumference at opposite ends of the cylinder. The point V is vertically above point Q. By considering the net, so basically the net is me flat packing that shape, find an expression for the shortest distance from P to Q when travelling around the cylinder. Give your expression in terms of pi, h and r. Now, this thing here is what a cylinder is. All I do is I'd fold it and it would end up like wrapping round like a circle, okay? And that point was above that point, but I've then put it over here. It's basically just made a right angle triangle, okay? It would be that distance there. That's what that is doing if I cut it up and flattened it out. Now, this is the height. That's easy to see, but this blue line here was the circumference of the cylinder when I unflattened it, okay? So when I flattened it, it's still the circumference, it's just been straightened out. The formula for circumference is 2 pi r or pi d, but it said it wanted it here in expressions of pi, h and r. So I've had to do it in terms of r here and not d. Okay, now then I want to find the red line. I've got a right angle triangle, so it would be doing a squared plus b squared equals c squared using Pythagoras' theorem. So as you can see here, I've written a squared plus b squared equals c squared. Then either way round, those two could swap if I wanted, but the main mistake will be not putting this bit in brackets, and when you actually square that, you should get 2 squared being 4, pi squared being pi squared, and r squared being r squared. So h squared plus r squared equals pq squared, and that was the final answer. Okay, in this question here, we're told in a class of 24 students, 12 play the piano, 13 play the guitar, 4 play neither instrument. Now, I'm going to just start answering the question here because I don't want you to see my answer yet. So, you're given a rectangle like that, but we need to go and add in 2 overlapping circles. There's a really easy number we can go and chuck into that straight away, which is 4 that goes there. Okay, I can put that there because 4 play neither instrument, so they go outside the circles. So this is going to be my piano, so I'm going to call that P, and this is going to be my guitar. Okay, now that means out of the 24, if we take away the 4 people who play neither, there's 20 people left who must go into these 2 circles. Now the thing that's hard about this is trying to work out which goes where, because we've got a number of students who play the piano, so there should be 12 that go in this entire circle, and we've got 13 who play the guitar, so 13 that should go in this entire circle. We're going to have an overlap by there, and the way to sort this out is to look at how many students play the piano and the guitar all together, by adding those together. So we get 12 add 13, which is 25. But we know there should be 20 in the 2 circles, so we need to go and find the difference between these 2 numbers. So if we do 25 people that play the piano and the guitar, and we take away the 20 people that are remaining that should go in there, then that is 5, and that has to be in the middle. Now, in the piano bit here, we know in total there are 12 people who play the piano. We've accounted for 5, so this must be 7. And then similarly here, in this circle, there should be 13. We've accounted for 5, so this must be 8. So if you have a look there, exactly the same way of me answering it there. It says a student is selected at random, work out an approximate. Okay, in this question here, it says work out an approximate the percentage of people who play only guitar. The people who only play guitar are the people in this bit here. Okay. Now the best way to answer that is to say it's going to be 8 out of 24. Now I was going to try and turn that into something out of 100, but then I realised that this fraction actually just keeps on cancelling down really nicely. So I then divided by 2 to get 4 over 12, and then I divided by 3 to get a third, and a third is 33.3 recurring percent. Alternatively, you could have tried to make that into something over 100, but it does say an approximate amount, so even if you got it to like being around about 100, it would be fine to be as an approximate. Next question says, find the area of the sector, leaving your answer in terms of pi. Now this is the formula you need to learn. This is the area of a circle, and then because we haven't got a whole circle, we've got 120 degrees. We'd say it's 120 out of 360. Now you'll be thinking, how on earth do I do 120 out of 360 times pi r squared without a calculator? Well, first of all, don't worry about that. Just sub it in because you'll get a mark for this line here. So the radius was 9, so I subbed in 9 for the radius. 9 squared is 81. And this fraction here you'll need to cancel down. So I've cancelled that down to a third, because 120 goes into both, so a third times pi r squared. And then I've done 81 divided by 3, which is 27. You can use bus stop to do that. For instance, you could have just done 381 there. How many 3's go into 8? 2, remainder 2. How many 3's go into 21? 7. So that's how I worked out that 27 there. And it said leaving your answer in terms of pi, and I've left my answer in terms of pi. I suppose you could argue I should have said centimetre squared there. Okay, another question as well on cylinders today. It says a hollow cylinder is made with an internal radius of 4 centimetres and a height of 10 centimetres. Carmen says this cylinder holds approximately 5 litres of liquid. By estimating pi as 3, show whether Carwin is correct or not. Okay, so you need to know this conversion here. 1 litre is equal to 1,000 centimetres cubed. It's also equal to 1,000 millilitres. And 1 millilitre is 1 centimetre cubed. They're the same thing. Okay, so we need to go and use the formula for a cylinder. So that would be the area of the cross-section, so that's a circle, times by the height. So that's going to be pi r squared times by 10. And the r is going to be 4, so it's going to be pi times by 4 squared times by 10. And they've told me by here to take pi as 3. So I need to change the pi to 3, so that's going to be 3 times 16 times 10. 3 times 16, if needs be, just go and answer it like this. You may be able to do it in your head, it's 48. So that is going to be 480 centimetres cubed. Now, he said it's going to take 5 litres of liquid. So, you can see I never finished writing that. So it will not take 5 litres. Okay, it will take like less than a tenth of that, okay, because 5 litres is 500,000 centilitres. Okay, I went mad with the cylinders in this question. Here's another question of a cylinder where they've given you the net, and very similar to that sort of Pythagoras question we did before, but again, they've given it without a calculator. I just wanted us to be aware of these sort of questions without a calculator. First thing I notice here, units are not consistent, centimetres, metres, got to have it into the same thing, okay? So I've got this into centimetres rather than changing that into metres because it's much easier to deal with. When I flatten that out, that red line there will be the circumference of the circle. It's me flattening that out. To work out the circumference of the circle would be 2 pi r. I've gone and subbed pi as 3.14. 2 times by 3.14 is 6.28, and then I've times that by 10. So that comes out to being a length of 62.8. To work out the area of this piece of card now, I need to do the 62.8 times by the 200, and they're both in centimetres, so that will give me an answer in centimetres cubed, squared even, sorry. So that is going to be 62.8 times by 200. I use the same trick as earlier. I split the 200 into 100 times by 2. And then I times that by 100, which gave me a really nice answer. No decimals, 6,280 times by 2, which I then doubled to get 12,560 centimetres squared. Okay, the key word in this question, again, make sure you've read it and you're familiarised with what it's asking you to do. The key word is this. Similar questions, similar shapes even, must have a formula that we use. And we're working volume here, and it tells us 2 volumes. 2 centimetres cubed and 54 centimetres cubed. So I've gone and written the formula that we've been learning, which is small times by scale factor cubed, because it's volume equals big. I've subbed into that, I've rearranged and found out the scale factor is 3. Now, I've used a little bit of logic here. It says, how many of the larger pebbles will be needed to form a straight row equal in length? Now, the larger pebbles means there'll be fewer of them, doesn't it? It'll be doing something like that, okay? But obviously that isn't the same length. It's just me trying to visualise it. So if there's 15 pebbles here, the smaller ones, it stands to reason there's got to be less of the larger ones. So what I need to do is I need to do that 15, something with a 3, have a think what it could be. It's 15 divided by 3 to get 5 of the big stones. Okay, question 18 is dimensional analysis. You must change the letters to L's. That's the way I taught you in class. So if I come and zoom in on this one here, S squared GH, I change to L squared times L, which is L to the power of 4. S squared G plus H, well, I've actually done the brackets first. L plus L would be 2L. And then L squared times by 2L would be 2L cubed. Technically, we ignore any numbers here. We don't need to worry about those numbers. This one here, you've got to be, oh no, this one's fine. FG again would be L plus L, which is 2L. 2 times by 2L would be 4L. And again, we could discount any numbers. We don't actually need to worry about those. But this is one you need to be careful with. Inside the bracket here, we're doing 2L and then brackets L minus L. Now the anticipation here is that you say, oh, L minus L is nothing, which is true if we think very, very algebraically. But if I have a length and I take away another length, it's going to leave me the length. That's what that L stands for. Okay? So it's going to be 2L, and then L minus L is still an L. It's still a length minus a length would still give me a length. And then 2L times by L would give me 2L squared. And like I said, we discount any numbers at the front. So we are now looking for areas, volumes, and lengths. I can tell you that this must be the area because its only thing is L squared. This has just got an L, so this must be a length. So this is an area. This one you might be able to guess because of the cubed. It is a volume. And then this one is nothing. There's no fourth dimension, so it's none. Okay? We'd also get none if we had something like L cubed plus L squared plus L. If they're different things adding together, which we can't actually add together, so you all have different powers, that they're all different powers, then that's none of the above. It doesn't work. Okay? They're inconsistent, we call them. Okay? So we're asked to find a length. So a length one would have been the 4L, which was 2 brackets F plus G. The volume was the 2L cubed, which was F squared brackets G plus H. And then it says, explain why f plus g squared cannot represent a length, area, or volume. Well, I said here that's going to represent a length and an area, which is inconsistent measures. To be a length, an area, or a volume, they've got to be consistently length, add length, take away length, or area, add area, take away area, or volume, add volume, take away volume. Okay, they've always got to have the same thing in them. These don't, hence they're inconsistent, so you can't have them. Okay, this is the all-important thing to remember for this final question. Frequency density is equal to frequency over class width. You need to learn that, not a bad idea to learn it. It's a triangle as well. It says, the histogram shows times taken by people in a group to climb a set of stairs. And we knew it's a histogram as well because it said it was measuring frequency density. And think about it, you're doing the final question here. Question 20, it's not going to be a case of just reading off the numbers on the side axes, okay? So it says, calculate the number of people in the group. So I've got a frequency density of 0.2 and I've got a class width of 30. So to work out the frequency, I multiply these two numbers together. So 0.2 times 30 is 6. I then repeat these sort of measures. So I'm times by 10, 0.4 times 10 is 4. This one here would be 0.8 times 10, and so on and so on and so on. And 0.1 times by 30. So I then added all those numbers together. Now, because it was a non-calculated paper, I found number bonds here, so that makes 10, that makes 20, that makes 10, so that's 40. Add the 3 is 43, so you can do that quite quickly. It then said, calculate an estimate for number of people who climb the stairs in less than 65 seconds. So I've got it marked here, so where 65 is, and that was really lucky for me because that was just clearly splitting the bar in 50-50, but you may have a worse case. Say it was like 62, you'd have to go and work out using the frequency formula, frequency density times by class width, and you'd have to work out the class width from 60 to 62 would just be 2. So you'd split that 10 into a different measure, potentially. Not in this case, they're both 5s. It's lovely because it's bang in the middle. And then because we wanted it less than 65, we were interested in these 6, these 4, these 8, these 12, and then 5 of that bar there. Added those together and got 35.